The second number, it's called the angular momentum quantum number, and that's L. This one indicates the shape of the orbital. So that's L. And I want to make sure you understand this. This could be numbers in a range. So these are numbers in a range. So it could be one number. Like if I have the range of 0 to 0, that's just one number, 0. But if I have from 0 to 5, then I have all the numbers in between as well. So be aware of this. There's a range. The word is often missed. And it goes like this. It starts from 0, and it goes to n minus 1, or 1 less than n. 1 less than n. So let's begin. If I have n equals 1, then L starts from 0 and anything less than this. So the only thing I have is 0, 2, 1 minus 1, which is still 0, right? So I guess what? L can only be what? 0. So again, from 0 to 0, and it's 0. Okay, anytime you have 0, this, since we said the shape, this corresponds to what we call an s orbital. An s orbital. If I have n equals 2, L now has to be from 0 to n minus 1. Okay, well, n is 2. So what is that? It's going to be from 0 to 1. 2 minus 1 is 1. So therefore, L can be 0 and 1. Okay. Now, we already said what 0 is. So the second energy level has 2 subshells, you can say. So by the way, this is called a subshell or sub-energy level. Only one subshell. And this is now an s orbital. But when L is 1, that's called a p orbital. So this is very important. So you can see when L is 0, it's an s orbital. Also there. So you have now 2 subshells here. So we have 2 subshells. If n is 2, it means you have 2 subshells. So you can actually derive that from that 2. 2 means 2 subshell. 1 means only 1 subshell. But be able to calculate L and the L values. Again, from 0 to 1 less than that. Or there's from one of my former students, one way of just remembering it, instead of subtracting and just going on the long way, is just write all the numbers that come before 2. And that's 0 and 1. Write all the numbers that come before 1. That's only 0. Once again, write all the numbers that come before 2. That's only 0 and 1. Write all the numbers that come before 1. That's only 0. So if I have n equals 3, what are the numbers that come before 3? 0. Okay, so here I'll write the range. 0 to 2. So that's only okay, let me write it next here. L is 0, L is 1, and L is 2. Okay, so now you have 3 subshells in this one. So that's S, that's P, and now this is D. And once again, you have 3 subshells. Okay, I'm going to move this down a little bit here because I need more space. I have n equals 4. That's the 4th energy level. So my L is starts from 0 to, I will write all the numbers that come before 4. So that's 0, 1, 2, and 3. Okay, well, we know this is S, that's P, that's D, and now this one right here is called F. It's an F orbital. Okay, so you have 4 subshells or sub-energy levels. So be able to derive those numbers. Very, very critical. Now, let me jump quickly. I'll come back to these quantum numbers, to the shapes. These are the shapes. S is a sphere. P looks like an 8 or an infinity sign. We're going to talk about the numbers that's coming next. And then D looks like a clover leaf, except the one in the middle. It has like 4 sides. So we usually say S is a sphere. P we say is just, it looks like an 8, or we say it's like a dumbbell for, you know, if you are at the gym, if you lift weight. And then D looks like a clover leaf. Okay, has 4 sides to it. F looks a little bit bizarre, so it actually has more lobes. Like this one has 2 lobes, this one has 4. If you look at F here, if you can count how many, excuse me, it has, some of them can have a lot. So you can count, you have 1, 2, 3, 4, 5, 6, 7 lobes, right? But mainly know the shapes of these.